Today we're going to talk about scatterplots. This is the next unit in statistics. And scatterplots you have quite a bit of experience with before in your previous math courses, but statistics is going to dig a little bit deeper into scatterplots and what they really mean, what they tell us about data. So the first thing that's a little bit different is when you're talking about a scatterplot in a statistics course, you're going to get really detailed in describing that scatterplot. So when you describe a scatterplot, these are the things that you need to make sure you include. You need to identify the variables. So you need to talk about what X means and what Y means. Then you want to describe the overall shape of the data. You want to talk about whether it looks approximately linear, there are clusters, whether there are any outliers, whether it's a curved pattern, the overall shape of the data. The next piece is the trend. The trend talks about whether there's a positive relationship or a negative relationship. So as you move to the right, is the data going up, which would be a positive relationship, or is it going down, which would be a negative relationship? One of the most important parts of a scatterplot is the strength of the scatterplot. You want to describe whether the relationship appears to be a strong relationship or a weak relationship. You also want to talk about any plausible explanations. So are there explanations for the pattern? Why does the pattern look that way? You want to talk about any lurking variables. And a lurking variable is something that you're not analyzing in X and Y that might cause there to appear to be a relationship. So is there something else that might be kind of hidden that might explain the relationship as opposed to an actual relationship between the X and the Y variable? And the last thing you want to talk about is whether it's generalizable. Can you generalize this pattern to other cases, or is that relationship all you get? So when you're talking about scatterplots and relationships, you're going to work with lines of best fit. You can sketch an approximate line of best fit, and then you'll do quite a bit of work using your graphing calculator to get an exact line of best fit. So when we're working with scatterplots and relationships, we want to have some way of quantifying that relationship. How strong is it, positive or negative? So we quantify that in statistics using the correlation coefficient, which is represented with the lowercase r. That measures the strength of the line. We'll tell you whether the relationship is positive or negative and whether it is strong or weak. If it is strong, it's going to be closer to 1 or -1. If it's weak, it's going to be closer to 0. One thing that you do want to consider with correlation is with scatterplots and lines of best fit, linear regression, you always want to look at the picture as well, because you may get what appears to be a strong linear relationship, but if you look at the data, there's actually quite a bit of curve to it. So you want to make sure that you do look at the actual data, the actual graph itself, in order to determine whether the straight line actually is the best fit. One thing as an aside I want to make sure that you always keep in mind is correlation does not mean causation. So because even though there is a relationship between the two data, there appears to be a relationship, that does not mean that one causes the other. You cannot ever determine causation unless you're doing experiments. The other piece that talks about the strength of the relationship is R squared. So R squared really is just that correlation coefficient squared, which will only give you a positive number. And R squared gives you the percentage of variation in the Y's that is explained by X. So really you're talking about if R squared is 0.86, that means 86% of the variation in the Y values can be explained by X, meaning the closer to 1, the better, because the higher percentage of the variation that can be attributed to that relationship, that means that that relationship is pretty strong. Just to reiterate how important it is to look at the graph, the other reason why you might want to really look at the graph is that outliers may change the line of best fit a lot. So you want to look at the graph, and if there is an outlier, it might be a benefit for you to analyze the data fitting a line without the outlier, as well as a line with the outlier, to see how that outlier impacted the data. So getting into this even further, and this is really the new piece that you may not have seen in a previous math class, is a residual plot. A residual plot is a new scatter plot where you plot the actual y predicted values versus the x. So you're looking at the actual y values compared to the predicted y values based off of your equation. So when you get an equation for a line of best fit, you find what that line of best fit would predict the y values to be. And then you compare that to your actual y values in your data set, and you're going to create a plot of that information. And if the residual plot has a pattern to it that has a particular curve, or it's always going in one direction as opposed to just being kind of a scatter all over the place, a line of best fit may not be the best predictor. And we may need to be changing the data in order to look at something that's non-linear.